Okay, here's the next one. Not a nice thing to think about. The acceptable level for insect filth in a certain food item is 5 insect fragments per 10 grams. A simple random sample of 50 10-gram portions of the food is obtained and results in a sample mean of X bar equals 5.7. We have a simple random sample of 50. They did not tell us that the population distribution was normal, but we have 50, which is greater than or equal to 30, so the sample size is large enough. The mean for the sampling distribution of X bar will equal the population mean. No rounding needed there. And the standard deviation will be the square root of 5 that we have for sigma divided by square root of 50, because 50 is the sample size. So square root of 5 was the standard deviation for the population. And we're not dividing by 50, but by the square root of 50. And they want that rounded to 3 places. The thousandths place, that's going to be 0.316. So what is the probability that we would get a simple random sample of 50 of these? With at least 5.7. That's going to be shaded to the right again when we say at least. So now we had a finite lower bound of 5.7. It would help to make a drawing there to make sense of that. You'd be shading to the right when you say the word at least. And then the shading would continue to the right. So we're going to have, not inverse normal. Normal CDF. So we're placing a finite lower bound of 92.1 with the 5.7. It keeps on going to the right. So I keep the 10 to the 99. Replacing the mean of 90 with a mean of 5 compared to the previous example. And I would be careful with taking the rounded version of the standard deviation of the sampling distribution of X bar. Sigma sub X bar being 0.316. You might get the answer, but I'm going to type in what I originally typed in. Which was the square root of 5 divided by the square root of 50. And let it take care of that calculation. And rounding to 4 places, the 10,000ths place, that 2 right after the 4 would cause this to round down to 0.0134. This is smaller than 5% or 0.05. It is unusual because the probability is small, smaller than 5% or 0.05. And because the result is unusual, okay, X bar was 5.7. And so it seems that, relatively speaking, that's not a lot higher than the 5 that was claimed for the population. And so it would not be reasonable to reject that claim that it was higher than 5. Oh, sorry. Okay. Because it is unusual. Got something so extreme that makes me doubt that the mean of the population is really 5. Maybe it's higher. I don't know if it's actually the 5.7 that we get from the sample, but there seems to be some evidence that it is higher than 5.